Okay, let's talk about a couple things real quick. I need to put this announcement out on Brightspace. Next week, next Tuesday, from 4 o'clock to 8:30, there is going to be a joint meeting between Indiana, Kentucky, and Ohio professional surveying societies, um, the local chapters, Cincinnati, Northern Kentucky, and the Greenville Treaty, here at school from 4 o'clock to 8:30. Um, we're going to have a few speakers. Carol's talking. I'm going to talk. We have John Greenlodge coming down from the Ohio State Board. He's like the head of the board, the chairman of the Ohio Board. A very knowledgeable guy. If you have any questions about licensing in Ohio, he is a good one to talk to. He's going to talk a little bit about ethics. They're also going to promote or give two PDHs or CDPs, however you want to say it, to professionals who might need that for ethics. Um, there will be food provided. There's a cover charge, however, students are free. Want to make sure that's important to know. Those of you who are going to the NSPS competition in Washington, D.C., it's kind of sort of mandatory for you to be there. Every other student is invited to go. It would be really good from like, what was that? Fundamentals or no. Introduction to surveying, how we, part of our, one of the assignments was joining CAPS or OSPS or ISPLS. This would be good for you to come and see everybody. You're going to see people from all three states. You talk to people from a local chapter. They would love to see the students there as well. Another thing we're going to try to do, depending on time, we'll also give them a little bit of a tour of what we have here, the facilities at school and the surveying, on the surveying side of things. So we'll go over to like 1:30, and they can see the kind of equipment we have, the lab space we have, things like that. All are encouraged to attend.
What will this be at, like actually in the school, like location?
I'm going to need to double check that. We hit a couple places. We were going to try to do the conference center, but that is booked up. We have two other places that we have. I need to double check with Carol and see if we got that one finalized. There's a like an auditorium area in the over in the health building. That was a potential location. Um, what should you wear? How about clean clothes? Clean clothes. I mean, what you're wearing right now looks probably would be acceptable. I don't think you need to get like dressed up fancy, unless you would like to.
I was just wondering because I don't want to show up and then like the guy from the board was dressed nice.
Oh well, he probably will be, but he normally does. You know, just some dress pants and a sport coat or something. I mean, nothing fancy, but that's him. I would say maybe come in looking a little better than you just spent a day out in the field covered in mud. How's that? We're surveyors, so look semi-nice, semi-professional would be the thing there. So that's coming up next Tuesday. I will double check with Carol on our final location, and I need to post this on Brightspace. Again, all are welcome. I know all the folks from all the chapters would love to see students. Uh, Next Tuesday, March 24th, 4 o'clock to 8:30. It'll be really, this is a really kind of exciting for Ohio, Indiana, and Kentucky. They've not all gotten together in one joint meeting before, so this is really neat. There have been some joint meetings before where like Ohio's invited Indiana to a meeting, small things like that, but nothing quite like this scale or all three coming together. So this is pretty exciting. Okay, so this week we're talking more about layout type things, basic layout techniques, chapter 19 in our book. This week's lab, we are going to lay out some utilities, storm sewer, sanitary sewer specifically. We're going to stake out some manholes and provide offsets with grades on all the offsets. So cut and fills, cuts to all the inverts. I don't have one of my amazing riveting special should be world famous boring presentations, PowerPoint presentations. Going to just kind of look at the book and go through the book here. Anybody have any questions on anything so far? Comments, concerns? I will post this lecture video later on in Brightspace after in my office hours this afternoon. Get that on. I need to update the lab. Real quick about the lab. Like I said, we're going to lay out some sanitary sewer. I'll go ahead and just show you real quick. We can talk about that briefly. Wrong paper. So this is the general layout. Everybody's familiar with the control points that we have used. These are the same control points that we used for the building stakeout. We staked out that building. It was kind of in this area last week. We're going to stake out a couple manholes. We'll stake the center of the manhole. We will provide offsets of the manhole. We will provide a cut or fill to the rim elevation, the top of the manhole, as well as invert elevations. Since we are here in Hamilton County, the school's located here in Hamilton County, we're going to stake this out per like a Hamilton County spec. What that means is along with an offset to the manhole, Hamilton County wants offsets laid out along the line at various stations. So your downhill manhole will say is station 0, going up station to your upstream manhole. We will put in an offset, probably like a 15-foot offset, something like that, at what would be station 0 plus 25, 0 plus 50, 1 plus 0, 0, so on, until you hit the next manhole. In the case of this run, that's only 75 feet long. We'll have one at 25 feet, one at 50 feet, and then an offset for the manhole. For example, where we have a run that's 140 feet long, we'd have an offset at 25, 50, 100, and then the manhole. Along with those offsets that are along that pipe, we will provide cuts to the proposed invert elevation of that pipe at that point. So what I mean here is we will provide a cut to this invert of the manhole. We'll have to calculate what is the pipe elevation, invert elevation at 25 feet up, and that's what we will provide a cut for. We'll calculate what is the invert elevation at 50 feet out, what is that elevation, and that's what we provide a cut to, 100, and then the manhole will be its invert elevation. Yes?
We're gonna do elevation 4. Stake out, that way we already have our elevations.
Here's how I envision doing this, and I need to update this lab. What I'm going to give you, you're going to have the invert elevations of the manholes. You're going to know the length of the pipe, which the 75 feet, 140 feet, 140 feet are, we'll say, are horizontal distances. So we're going to do the calculations, and we're going to calc that ourselves, okay, by hand. Calculate what those invert elevations should be at that point. Same calculation style as back in survey fundamentals when we did the contours. You know, rise over run equals slope. We know the slope. We know the run. We can calculate the rise and calculate the invert elevation from that. When we get out in the field, we're going to have just points on the sanitary manholes themselves. Those points will have elevations that are the invert elevations. When you go to stake that out, it'll be like we did with the building here. We're going to stake out a baseline. From starting point of our baseline will be the downstream manhole. The end of our baseline will be the upstream manhole. And when we say we want to go station 25, 0 plus 25, and go 15 feet left or right, it will calculate that elevation for you and provide that when you put the hub in the ground and have your cut. I'm going to have you hand calc.
Like that 140 foot line, and you can pick up elevations along the line.
Right. We'll know the elevation of the invert for manhole 2 and the invert elevation for manhole 3, I believe that is up there. We know it's 140 feet long. We know it's running at 15%. So we can calculate by hand what is that 25 feet up, 50 feet, 100 feet. So we'll do those calculations by hand. So we do have those. However, when you get into data collector, you're going to have this point that's going to be at the invert elevation, point up there at that invert elevation. When you say stake out that baseline, and because the data collector knows those 2 points at that known elevation, it knows the slope, the distance, and as you go along that line, it will calculate for you the invert elevation. So I want you to have a little bit of old school math of how we used to do this way back when, and then when we get out in the field, here's going to be how it's a little more like in the real world scenario if you're laying this out with an instrument. This lab was put together. This is all like elevation, or well, I think the elevations are actually pretty close to a real world spot. But as far as the horizontal placement, they're like a 5,000 coordinate system. I have moved, like, our coordinates are actually real world GPS derived coordinates. So I need to move that up, and I'll probably tweak the elevations a little bit so they're a little bit closer to reality. Anybody have any questions on that? Any other questions on that? It's going to be the most fun lab ever since the building layout lab.
Can't wait.
All right. That's a go-getter attitude I like to hear. Way to go. So that's kind of this in a nutshell. Again, I got some work I need to do with this to get this ready for Thursday. So we will go outside Thursday and stake this out. The way the weather's been, who knows what it's going to be like out there, but dress accordingly. Probably would recommend some boots and a coat just in case. So yeah, dress for being outside. And we're going to have the most fun ever. Thursday. I don't know what the weather is looking like right now for Thursday. However, I'm sure it will probably change between now and then from whatever you see on your forecast.
40s and rain.
40s and rain? Awesome. Last time I didn't see any rain, but like I said, that'll change between now and Thursday, so who knows? We'll see. We will get done what we can get done. So let's kind of roll through the book here a bit. Chapter 19 in our construction surveying book. Talking about planning, rules of layout, checking the layout, and learn from mistakes. Kind of getting a plan together is very important. Having a plan how you're going to lay this out, what the contractor needs. Um, there are a lot of companies today, I believe, that would just give you coordinates to everything with all the elevations, all proposed elevations already provided. I'm going to give it to you as you have minimal information and let the data collector do a lot of the calculating for you. Um, Another kind of nice thing about having this minimal information and doing the calcs in the data collector, maybe the office folks give you a 10-foot offset of these manholes and these the run. You get out there and the contractor's like, hey, can you, I don't want a 10-foot, can you give me a 15 or a 20-foot because it's really deep or something? Hey, no problem, I got you. You don't have to call back to the office. You don't have to say, hey, I need coordinates here instead. You can do it, take care of all this stuff immediately right out in the field. Planning is very important. Checking, checking your work, check, double check, triple check your double checks. Redundancy builds confidence, all those other fun things that I like to say all the time. I hate when I set my glasses down and can't find them again. So we kind of talked about planning a little bit. The very first activity, a lot of this stuff too will also kind of happen in the office as far as the logistical standpoint. When the contractor calls the office, says, hey, I'm ready for your surveyors to come out. I'm ready for them to lay out the sewer. Sometimes, not all times, the construction company, their office folks call the surveyor's office folks and they coordinate. Once you get out in the field and the survey field crew's out there talking to the contractor who's actually out there going to do the work, things might tweak a little bit. Like I said, maybe the office said, hey, give us 10-foot offsets, and you get out there and realize, oh, we need 15 or 20-foot offsets, something different, something changed. Stuff like that. You want to coordinate and talk to the contractor when you roll up on site. Visualize the project. You want to kind of look over the plans before you get out there on site, kind of get familiar with what's out there, what the proposed is going to look like. I'm a very visual person myself. If you need to start drawing sketches, that is recommended to kind of help make everything come together in your mind. Sketching is very good. Again, the schedule, that's probably going to be done more so with the on the office side. But they will coordinate with you. Okay, here's the plan. You have today you're going to go out to this job site, stake out this sewer. The schedule can get kind of tricky sometimes. I've had this happen a few times myself where you get out there, your plan is to stake out the sanitary sewer, and the contractor's like, well, we're not quite ready for that yet, but can you, while you're here, can you stake out this instead? Or something like that. If something like that happens, what you would need to do is call the office, your office, and let them know, hey, I'm on site. I talked to the contractor. He's not ready for this. He wants this instead. More of a just kind of an FYI, let them know what's going on. Your crew coordinator might say something like, yeah, that's fine, go ahead. Or we got you scheduled for this and then you have to go to this other job. We can't do that. Either way, let them know up front. Communication is very important. Consulting. Again, I think that kind of goes with talking about when you get on site, talk to the contractor immediately. Let them know you're there. Let them know you're scheduled to do. Make sure that you have all the information that you need to perform what they need. Make sure nothing has changed. I mean, you can plan as much as you want for the offsets, and that usually will work out. However, there have been times where something comes up. They're like, no, we actually would rather you change our offsets and give us something different. Try to plan for it. There's a lot of times where some offsets are relatively standard. For example, you're staking out a roadway, 3 foot offset of the back of curb is pretty standard, at least in this area. Other places, other contractors or other municipalities might require a 4 foot offset or something like that. Uh, Buildings and things, a lot of this, and even like sewers, the offsets can vary depending on how deep they have to dig. So, for example, I've seen places where they've dug some really deep manholes, and a 15-foot offset would not be far enough because they have to dig deep, so they have to dig out wider. Maybe they put shoring in or have to bench it, something like that. It can vary, it can change. So, being flexible is very important. Offsets can be generally consistent, but it does depend on how deep they're digging. So what Wesley Crawford has here for rules of layout from critical to non-critical dimensions. I think we kind of might have mentioned this before. A good example here would be, say this is a hotel. There's a column in the middle that's going to be for the elevators. If you go out driving around, you see where they're building new hotels, new condos, new apartments, things like that. You'll see that shaft is like the first thing being built and first thing that's up in the air. That would be your critical. Work out from there. Um, that's just one example. With bridges and other things, the abutments, those could be very critical on bridges. So this is another kind of refers back to looking at the plans, getting yourself familiar with the plans. What is, if you go out there and they decide, here's what's critical, we need you to lay this out, you start there. Begin at the middle and work out. On some types of building projects, it's good practice to establish the center line control and then work from that. I've seen that too with other buildings where you stake out column lines. Columns are usually running through the middle. These are like in bigger buildings, bigger warehouses. That is the contractor's control. They start with those column lines and they build out from them. Another good example of critical dimensions, starting in the middle, working out. When you're dealing with smaller structures, buildings, that's not necessarily as important. If you're staking out a house, you can stake out the corners, stake out all sets of the corners, and you're gone. Bigger buildings, bigger projects. I've worked on hospitals and things like that. Actually had a situation in Clifton Children's Hospital where we were not involved with a lot of this stuff, but what was going on is they had the building built. They're like 13, 14 floors. And then the different contractor was coming to put the face of the building on. And there was some arguments between the people who built the building and people who were going to put the face of the building on, as far as things weren't lining up matching. So we ended up actually going and setting control on every floor and said, okay, this is it. This is what you're working off of for everybody. Try to kind of help eliminate. We kind of came in later as a third party to that. So that was pretty exciting too, I ended up being on the roof of Children's Hospital at one point. Yeah. No, thank you. Land surveyor. It's in the title. Not height surveyor, land surveyor. I prefer to keep my feet on the ground. However, there are times where, I've also been up in scissor lifts measuring things and laying out some columns for overhangs. I've been on brought up in cherry pickers up against the sides of buildings. I'll tell you what, man, that's very nerve wracking, at least to me. Climbing up in ladders, getting on top of forms. Yeah. Construction staking, you can end up in some really odd places sometimes. Uh, yeah, I've actually had the chance of doing that too, measuring some, getting some topo, getting ground elevations for detention basins and retention basins that were already full of water. Go out like in a kayak and lower the rod and take a shot, paddle somewhere else. Oh yeah, that's well, yeah, down south where you got crocodiles and alligators. Yeah, no, thank you. In the Midwest, fortunately, we don't have to worry about stuff like that. I've actually had instances where I was walking through with some hip waders through creeks, getting topo for gas pipelines crossing creeks where they were starting to erode and get exposed. And you're kind of walking along, and all of a sudden you slip and fall off and go in. Yeah, not fun.
We just got not that long ago that we just got that big one of the last big rains we got, and is kind of the bottom ground there, and everything was flooded. We were like, we can't even get back in there. I mean, the water, rushing through there.
Yeah, yeah.
And it's weird. It's like all flat wood, but like the current was strong. We were like, we're not going in there. We'll come back later when it dries up.
Yeah, there were some of those jobs where we're doing that for Duke Gas, where pipelines were crossing creeks, rivers, streams, and it was eroding, and they needed to get some topo of what existing conditions were like and what was exposed to the pipe. So we're walking through, getting shots in that stuff. There was a spot on the north side of Middletown in the Great Miami River where we took a John boat with a motor, and they actually used the little sonar, and we're driving back and forth because the current was moving pretty quick, and we weren't really sure what the existing conditions were like with the depths and things. Be careful out there. Lots of fun. I can also tell you from experience there too, it gets a little scary when you do slide and go under and the top of your waders go underwater and they fill up. You're like, oh, am I going to be able to get out of here? But hey, I'm still here, so it worked out. Avoid cumulative errors. So when laying out consecutive distances, for example, 25-foot column lines across a building, it's good practice. It is not good practice to individually measure the 25-foot increments. What they're saying there is what you should do is hold 0 and measure and mark 25 feet. Holding that 0, go 50 feet, go 75 feet, go 100 feet, and then move up. Not do the 25 feet increments individually. That's something we used to do a long time ago, pre-robot and everything, where staking out curb, we would pull a tape measure and go, or 25, 50, 75, whatever, then move the tape up and keep going where we were just turning angles and sighting them in. Does that make sense? Hold a 0, pull your tape as far as you can, and then move your tape, and then do your increments. Now, in this day and age with like the robots and things to that nature, that's kind of irrelevant. However, it's still important as far as a process to keep in your mind good practice, avoiding cumulative errors. Use long back sights. Long back sights and short foresights during layout. This also helps reduce errors. I was actually talking about this in another class. Um, there's a little formula there where S could be your positional difference times R being your length times theta in radians. So if you're off a couple minutes or a couple seconds, the further out you go, the further distance gets. How far positionally off you can be. So long back sights are really good to short back sights, never the other way around. Do not take a short forced back sight and push out a long foresight. Surrounding the sight with control. Very important concept. Um, Make sure you always have long back sights, short foresights that are available for the layout. If control is always on the outside of the project area, longer back sights will automatically occur. Your primary control, it's good to keep on the edges or outside. Turn control into the site. If that's not quite the option, what you want to do again, look at the plans beforehand, get familiar with them, see where are grading or limits of disturbance going to be for a project. Try to set control outside of those disturbed areas or where proposed work is going to go. There's going to be times where you do need to turn in a point and set something in there that you know is going to get wiped out eventually, but you need to get something in to start laying out something. That's fine. That happens. Try to keep your primary control outside or along the edges as much as possible. It's kind of dark, isn't it? No. Checking your layout. It's always important. Check, check, double check, triple check, double check your checks. Um, Obviously, to help avoid errors. Changing technology is always a good idea. If you're laying something out with the GPS or with the robot, you got some stakes in the ground, pull out a tape measure and pull distances between your offsets, between hubs, just to verify everything is set correctly. That's what changing technology means there. You lay out with instrument, GPS, change technology, pull out tape measure and pull, make sure, verify your distances are correct. I would definitely recommend doing that in crucial layout, such as if you are doing a big building and you have column lines. Pull distances, check your distances. Don't just blindly accept what the data collector tells you. If you're staking out catch basins, manholes, fire hydrants, if you're within a general area, you should be pretty close, whatever those tolerances may be required for that site. When you set the center of a structure, you're pretty much going to just put a lath in the ground. Here's the center of the structure. That can be within, I'll say, a tenth or two. I think back to a crew chief I had. I was trying to get him just perfectly in the center of a manhole. Put a lath in the center of a manhole. He's like, it's a 4-foot manhole. I'm close enough. That center stake is going to get taken out anyway. The offsets are more critical. You want to get within a few hundredths on that. When you're staking out those column lines, very critical to be as close as you possibly can. Changing the methods. When checking, it is imperative that alternate methods be used. Never ever check a layout by using the same procedure that was used to perform the layout. Change the method or the equipment or the control points and perform a check. Sometimes this isn't always practical due to time constraints of a job. But when possible, to check and double check your work, verify it is, maybe step on another control point, shoot in what you've laid out to verify that you're within tolerances. Check for design errors. When the layout is complete, check the overall scope of the project to see how the structure that was laid out compares to other structures or site work. Look for design errors that can cause things not to fit or cause them to look unusual. What looks good on the plans may not look good on the ground. Immediately inform superintendent of any discrepancies. I would also recommend, while you're putting things in the ground, take a step back and look at it. Does this look right? I've seen instances where coordinates were given for staking out a parking lot, 3-foot offset back a curb. I had 2 offsets for a corner, one coming in off of one line, one coming off the other line. The corner was one elevation. The offset over on one side had a cut of 3/10, and the offset on the other corner side had a cut of like 1.30 for the same point. And the ground was relatively level. It's like I got 2 different grades here that are drastically off what's going on here. Check your points. Take a step back and look. Like, does everything look sensible? Does everything just look good? Because there can be times where if you are getting points picked off, it's always good even to check the coordinates you're given to verify, are these points at the proper elevation? Are they in the right location? Do they look correct? Learn from mistakes. Everyone makes mistakes in layout. Mistakes have been another topic that has been consistent throughout this text. Everyone recognizes mistakes will be made in layout. It is more important that the persons learn from their mistakes and avoid making them again. I like to say smart people learn from their mistakes and wise people learn from other people's mistakes. I will also just add to that too. When you're out there, first job, first time doing this type of work, observe. Watch your crew chief, watch the other employees that you're working with. How are they doing things? You can learn a lot from them. Okay, I don't know how to lay out this manhole, this catch basin, this building, whatever, but I'm working with people who do. Watch how they go about it, watch how they're checking, watch how they learn, or watch how they are doing the process and learn from that. It might not even be bad. Like, hey, have you ever had an incident where you made a mistake on doing this? Why did that happen? How did you fix that? Or, learn from other people's mistakes. But realize mistakes do happen. People transpose numbers, fat finger a coordinate, a variety of things. Any questions so far? Pretty riveting stuff. Okay, so next part of the chapter here, talking about control. Talk about the site, contact professional surveyors, select the layout method, design the control, monumentation, horizontal, vertical controls, preserving points, and referencing. I guess I'll just want to add this too. When it comes to the checking and trying to avoid mistakes, just kind of pretend, say to yourself, I'm the professional surveyor that has to stamp this work. Am I comfortable with everything that I've done so far? Would I be okay with what I did and how much checking I performed? Yeah, it's pretty easy to sit there and go, yeah, we're good. It's not my stamp. don't be like that. Put care and effort into this. This is a chosen profession that we are getting into. And eventually you want to work towards becoming that licensed surveyor. There's a lot of liability with that, a lot of responsibility. Just ask yourself as you're doing your work, say to yourself, would I be comfortable stamping this? Did I check enough to where I'm comfortable if somebody comes back and says, hey, there's a problem? I can show my work, prove my correctness, or anything along those lines. Okay, now control. Project control is the horizontal and vertical from which everything is going to be laid out from. So again, planning where you are going to place your control is important. Making sure you have enough control. When it comes to setting benchmarks, this is one thing I'm not going to lie. I was sometimes not the best at setting benchmarks or forgetting to set enough benchmarks. The benchmarks, particularly in construction layout, contractors are going to be using those benchmarks as well. So you want to make sure you set good benchmarks that will last and that are easy to use. It's also good when you are needing to set benchmarks, talk to the contractor who's out there building the site. Hey, where would you like some benchmarks at? Where do you need the benchmark set? A lot of times when they start building buildings, they start getting the slab in, or before they pour the concrete slab, depending on the size of the building, they might want some benchmarks set within the footer. And we want this pin set so it is exactly at the finished floor elevation. That's a little challenging, but it's doable and it's not uncommon. We know that benchmark's going to be taken out. It's not going to be used for very long. However, communicate with the contractor, see where they need benchmarks, make sure they're usable and friendly. So contact the PS. Long before the project begins, the survey team will establish boundaries and geometry of the project site. Do not proceed without information from the surveyor. That is something that is fairly important too. I mean, we're going to go out and stake out. There's going to be a new UDF or Wawa or Buc-ee's or whatever, a new gas station, a new strip mall, anything. Somebody had to do a boundary survey first, and everything that's being built, there are zoning codes, minimum setbacks, things of that nature you need to be aware of. Make sure you are tied in and in the right location as far as the boundary is concerned. A lot of times, from my experience, I worked with in companies that were engineering and surveying companies, so we did a lot of the boundary work in-house. It went to the engineer. Then they do the design work, and then we go out and did the layout immediately after. There are times where a surveyor may do a boundary survey, may do a base map, and turns that over to their client, who then in turn hires a different engineer to actually design the site. Stuff like that happens. Yes.
So do you stake out gas stations? This is a wrong question. Do you stake out the gas pipes where these come out of?
Where the gas pipes come out?
Yeah. Do you use something like that, or
Not necessarily exactly like where the gas pipes go. I've had more experience with, like, say, the islands are of where the gas pumps are going to go, and they'll run in the gas lines, or I don't know how. I'll be honest, I don't know how gas stations are actually really built. I don't build anything; I just lay it out.
Yeah,
All I know is that they put a big ass tank in the ground.
They put a big tank in the ground. Yeah, Now, is that tank right underneath the gas pumps? I feel like sometimes I see like sometimes they're pretty far away,
Usually
off to the side a bit. So
ground.
I'm sure there's some gas lines that run too from the
There
tank.
has to be, yeah.
Yeah. I'm not going to say this is always the way it works, but I would guess a lot of times with that, you would probably stake out like the concrete pad, the big overall concrete pad of where all the gas pumps are going to go. Then you have grades for those the concrete, the finished concrete. They'll probably use that outline to dig and know how deep to build put those tanks in the ground.
They have different, you probably have to stick out, or maybe they do there's different valves that they, like our local gas station, well, we live out in nowhere, so they have off-road diesel for tractors, they have regular diesel, and then they have, you know, different gas, have different valves to operate stuff.
I've never gotten into laying out that kind of detail. Usually, I'm going to say you're probably going to stake out more like here's the area that of the concrete where all the pumps are going to go. Here's a grade to the finish concrete elevation. Then from there, they know, okay, here's how big my tank is. I need to have so much cover, and they'll just dig within that area and put them in accordingly. That would be my guess. I could be wrong on that. I've done more as builts of gas stations than actually laying out gas stations, but
They go in and they pin the dirt and all that stuff to like make sure everything's flat. And then the first thing that like my company does is that they stake out where the tank's gonna go. Because the tank is the first thing that usually goes in. Because I didn't know this, but it apparently has to sit in the ground for so long before it's used or anything.
oh really?
For some reason. Yeah, like so gas stations are not just like I figured it out are not just like built and then you can use them. They have to sit for like a couple years or something like that before.
Hmm.
I got told by Doug, but they like have to sit for a while. So the first thing they usually do is put the tank in because they have to sit in the ground for so long.
Yeah, it took them about 2 years to build. There's a speedway on 104.
Mm-hmm.
When you're first coming into like Columbus, and it took them a couple of years to build that, and they had to tank the ground first thing, but then they kind of built the gas station around it, finished it before they even brought gas in.
And then usually after the tank, they'll do sewers and all that stuff and lines because we have to stake out lines to where it's this, and then it goes to building, like you said, the concrete pad and all that good stuff. And then after that, it's usually light poles. And then once the light poles are in, that's like the last phase that we do for UDFs because like UDF hires somebody from where was it? Somewhere up north, from Minnesota. They hire this company from Minnesota to come down, and this company just does the rest.
Okay.
So we sign up for UDFs.
Okay. Okay. There we go. We learned something new. There we go. Yeah. I don't build anything. I just lay it out. That's what I always say.
Well, I asked all the questions.
And
I'm
that's
curious.
good. Yeah, that's good. I like asking questions too. However, I think of like in my case. So one time we were down at the Jim Beam Distillery, and we were out in the field where they have barns, and it's where they store all their barrels of bourbon to age it. In this one particular place, that was they were checking to see if it was the barn itself was in a floodplain. So we had to go shoot some elevations, run in some elevations, and shoot around it, kind of like for a floodplain flood certificate. Now, while we were out there in the middle of this field, just barns. I mean, nothing crazy around us. We had to be escorted on site. So I'm asking the guy more about like how's the whole process of making bourbon and things like that. not necessarily worried about anything else. But no, it's good to ask questions. How is this actually being built? Yeah, good to know. I mean, I'm just kind of guessing a little bit. Like, yeah, you're probably going to stake out the area where that's going to be, give them a finish grade. They're going to dig wherever and however they need to off of that stuff to put it in.
All that because we offset it because the tank, I know where it's at because it's in Beachmont area, and it was like the front left corner of the site, and the building was smack right dab in the middle. And I was like, so how are they gonna do it? I'm like, yeah, they just order the pipe. That's what the dude told us. I'm like, wait, how do they know? And they go, I don't know. They just order it, and then they come down and they do it overnights. Like apparently they work for like 24 hours straight. And
Oh,
they
wow.
like stop working and they switch off. It's like every other day they're on site. Weird.
Wow. Different job sites are very different. Gas stations apparently pretty different. A little different than laying out a McDonald's or a Chick-fil-A or something like that. Cool. Well, that was fun. I enjoyed that.
First time I ever did one, thought we were laying out like fucking UFO pipe at our sighting. That's why I asked. With all the like floating paint ribbons that are sitting up the flares or whatever you want to call them.
Yeah.
I'm like, what is this? Like, they want to know. I walked around the whole entire site just every so often. Put one here, and you take a hangnail and ink ribbon that stands upwards and it goes back on. You slam on the ground and do like 10 feet going around on the ground.
Yeah.
So apparently that's how they do it. So they know where like that tank is going to be the building. That's where that's going to be, and then light poles and stuff like that. I don't even don't get it done. Somehow UFOs still land.
Interesting.
I was waiting for it.
I was on a job where we were laying out geo piers for a.
I absolutely hate you.
Oh yeah.
I've done like 6 of them since I
So,
started. My first week there co-oping,
yeah.
I did 3 back to back to back. My first week, I was nope.
Yeah. So you're laying out a grid, a very tight grid. Um, usually just sticking a nail with like those
Yep.
whiskers sticking out of the ground because they're just going to come with the crane and their auger bit and just drill right there. Boom, boom, boom. Yeah, it's pretty wild. It's interesting stuff. Had a lot of fun down on this one site. It was down by Lunken Airport, the Duke Energy site. I was staking these out, and I needed to get like right in between the tracks of the crane that had the auger was drilling these. Made eye contact, waved at the crane operator. I'm like, hey, I need to set one right here. You go with that? He's like, yeah, fine, I see you. So I went around and I'm down there bent over getting ready to put this in, and he just tapped the stick, and that whole crane jumped. I about went out of my skin. I look up and he's just laughing at me, pointing at safety, making eye contact with the uh, equipment operators. Hey, I need to get over here. I'm going to go here. Make sure they know you're going to be in that area, so they can mess with you. Right? Yeah. You will. Don't get pancaked. Select the layout method. So once you understand the scope of work and understand the site and the equipment and personnel that's going to be available, um, start consulting with the superintendent, construction foreman, to see who the ones that will be building and decide on a construction procedure that will be used. For any project, any of the main layout methods, radial intersections, baseline offsets, 345 could be used. Does anybody know what that 345 means? That's a right triangle. Really fascinating here. Pull out your calculator if you don't believe me. Say if this leg is 3 feet, This leg is 4 feet. The hypotenuse is always going to be 5 feet. That will produce a right triangle. Now, obviously, you can use that as like a ratio, but yeah, 3, 4, 5. Easy way to, if you even have a tape measure, pull 3, pull 4, check your 5, and you can get a right triangle. You obviously expand that as needed, but that's what that 3, 4, 5 stands for. Some methods may be more efficient than others for various project types. You're laying out a grid, you're laying out geopiers, a baseline is wonderful. You're laying out a building like we did with the last lab, a baseline. We said, okay, we established a baseline by a starting point and end point. How far up the line, how far over the line. The data collector did all the calcing for us. We did some of that hand calcing first. Radially staking stuff out, like curb, for example, is probably going to be most commonly staked out radially. And where you just set up on one control point, backside another control point, and just start throwing points in the ground. Just boom, 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 keep going. We actually kind of did that in a way too with the building layout. We set on a control point, backside, and we whipped everything in from one spot. That baseline would be if we actually set up on that begin point, end point, did our up and overs from that baseline, actually physically occupying it. I also kind of like to think with the layout method, what is also going to be acceptable to think of. GPS is very common and prevalent today. Um, are the site conditions good for GPS? Is it a good GPS environment? Or do you need to pull out the instrument and do your layout using a total station? Uh, don't get so reliant and believe GPS is the be all end all. There is a tool for us to use. Sometimes it works wonderfully and will be sufficient. Other times, the total station is going to be your best option. And I think of an example. I was over in Blue Ash. They were expanding a food production site. They're adding on to the building. The guy on the equipment had machine control on his bulldozer, so he's got GPS units. He's going along a prefabricated concrete wall that was like 20, 30 feet tall. I was staking out sidewalk and curb right along this. I had my instruments set up kind of out on the street, and I was shooting into it. The guy with his machine control running up against this building is telling me my grades are off. That's not a very good GPS environment. You're getting multipath. You're not going to get good results when you work up against things like that. That's a case where your instrument's going to be a lot better. Guy got off his machine control bulldozer, went, talked to the super, said, hey, your surveyor's not laying anything out right. None of these grades are working. And the site super came out and grabbed me and said, hey, here's what's, none of these grades are working. What's up? I said, well, first off, he's using GPS right up against that building, which is not a good GPS environment. I got my instruments set up here. I'm measuring angles and distances off of that. What do you think is going to be better? And he kind of looked at that. He looked at the instrument, looked at the guy, and looked at the building and said, okay, we're good. Told the guy, go off of the stakes. Environment has a lot to do with things as well. You're staking out rough grade throughout a site that's already been cleared. Yeah, man, GPS the heck out of that. Go for it. Run. It's just, from what I've seen before I left the field and came out, just seemed like so many people were very reliant on GPS. Like, that's just it. I'm just getting this out, using it, and it's always going to be good. Not always. It depends on the environment. Depends on what you're doing. A lot of times I just felt like I worked a little bit faster with the robot than doing GPS as well. When you get there to store a point, you have to wait 2-3 seconds to actually store point, whereas with the instrument I'm there, I'm getting real updated positioning stored immediately. I just felt more comfortable with that myself, especially doing topo. Man, you get out in the road, you can walk and just good, 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 good. Versus with their GPS, you're sitting there waiting, good, sitting there waiting, good. Is the car coming? Waiting, good. You could just kind of get in and out of areas a little quicker.
And such that you gotta tie into an intersection on a survey,
Mm-hmm.
go like a mile, and getting real good signal to begin with, so then you gotta wait to get good signal, and then you gotta have somebody flagging traffic for you.
What I myself have actually done, and in cases like that where you're way off, is I would take the GPS, set 2 control points off the side of the road, set the instrument up on that, backsite the other one, and spin that stuff in. That's what I have actually done in the past. Just a little quicker, a little safer, in my opinion. Again, my opinion. Designing control can be very tricky. So you want to, again, make sure that you can get control that's going to stay through the duration of the project. Keep it out of areas where construction is going to happen. Uh, Things you want to watch out and plan around would be traffic obstacles, stockpiling of material, the job progress. So as the site changes, um, weather related, target stability, construction interference. So, yeah, you could have 2 points set, and then next week when you come, they got the forms up and they got scaffolding up. All of a sudden, you can't see between your 2 points. That also kind of fall with the construction interference, job progress. Weather related, I've had this happen a couple times. Set a control point. I actually saw this with the capstone last year. Capstone class, they were in a cemetery um, doing survey work, and they had a control point set kind of down in a lower area for topo that they were going to do. And when they went back the following week after heavy rains, the control point was underwater. So being mindful of the situation. Okay, you're in a cemetery. Nothing's going to be graded. Nothing's going to be changed. Should be pretty good, pretty stable. However, look for low-lying areas and possibly avoid those potential flooding areas. I did feel bad one time. I was doing some work out in southeast Ohio near Rio Grande by Bob Evans. There's a vocational high school out that way. I set a control point. I was in the wintertime. I was doing boundary and topo work. Had to go back in the spring, and my control point, once all the snow thawed, turned out to be right in the middle of their garden. Yeah, it's kind of a little hard to get to. But hey, it's covered in snow. How do you know? It wasn't very well marked under a foot of snow when I first was out there. Stockpiling material, boy, that's a hard one. You think you might have something out of the way, and then next thing you know, that's where they're stacking pipe or building trusses or whatever. Try to be careful of that. Try to keep careful. And of course, it never fails to, it seems like wherever you want to set some control points, that's also where they want to park their equipment. I actually made a comment like talking about setting control in the air class and referencing it. So taking maybe measurements to existing things around so you can come back and find it, pull in off of like, yeah, I set this 20 feet from the fire hydrant and it's 5 feet off of the back curb or something like that. Just kind of some quick references. Because it seemed like construction things, they see a stake, that's where they want to park everything by. Maybe you set your point, don't put a lot of stuff around it, reference where it is, and then 30 feet away, put a bunch of stakes in the ground to look like that's where your control point is, so they park over there. Yeah, it's kind of more of a joke than anything. Don't. Very true. I wish I would have thought about that a long time ago. Monumentation is very important when you're setting your control. This really comes down to what's the duration of the project. How long are you going to be there? You're doing a boundary of a farm or something like that. You're going to be out there for a day, a couple days, maybe a week at the most. Construction sites, you're probably going to be out there for months at a time. So you want to set control that is going to be durable and last. Uh, worked around. I've worked around in power plants. We actually had to set concrete monuments around in that because they were going to use that for future development as well as they added and did more work around that. They wanted something that was going to last forever. I personally would recommend, say, like, especially for construction sites, a minimum of like an iron pin. In Ohio, you're going to see mostly an iron pin being a piece of rebar that's 5/8 inch diameter, 30 inches long. Um, Personally, I'd recommend staying away from driving like mag nails in the dirt or hubs. Those can freeze and thaw and kind of heave a little bit. Easy to lose, easy to kick a nail out of the ground or some kind of bad thing to happen. Not very permanent, in my opinion. If you need to throw a point in just to lay out something really quick or locate something really quick and you're just going to use it for one time setup, maybe you do just stick something in the ground just for one quick, we say, real down and dirty, just get this done really fast. You're going to put a lot of hubs in the ground for your offsets. Hopefully they do last. Now I've had times where contractors called up and like, hey, we need these offsets, we need this staked right now. And then you get a call back a month later. Hey, we're ready to stake that or build that, and we need you to come out and check those hubs. Or some of those hubs got knocked out. We need them right now. And then another couple weeks go by. Hey, we're ready to actually build that. We need you to come out and replace those hubs or stake them out. Stuff like that happens. I would be a little leery myself of using a hub as a control point that you're going to use for a very long time. And I just think of like how contractors, they need something right now. You go stake it out, and then a month later, hey, we're ready to actually build that. Can you come and check, make sure these hubs are still good? So that's kind of my pitch on saying, I don't know if I'd be very comfortable setting hubs for long-lasting control. If you got concrete, cut a cross notch in there. Take your angle grinder, cut a cross notch in the concrete. Or if you've got asphalt around, drive a mag nail in the asphalt. Should be sufficient.
Is asphalt really that spongy? You just drive a nail right into it?
Like a magnet.
Or a magnet? Like one of the tiny ones that you.
Yeah.
Yeah, really?
Yeah.
You mean like
I don't know if I would say spongy.
Like the little ones, just got the rubber ball.
Oh, no. They're bigger. That would be like a tack that you're just going to place those in a hub. Yeah.
I thought you mean you take one of those and just right out of the ground.
No, however, I have seen people take those tacks and just drive them straight into asphalt and call that okay. I don't think this is actually ideal. Yeah. Yeah. Again, I would kind of. What's that? Oh yeah. You take a mag nail, push it into the asphalt with your hand.
Nasty blister all over my left thumb on 4th of July because we melted the asphalt with our fireworks.
Yeah.
I stuck my thumb in it like a total dumbass. Just full face with my thumb directly into molten asphalt.
Yeah, that's not a good idea.
Reason.
I'm guessing you learned from that mistake.
I did.
Okay.
It was very painful.
Here, let's go back to the beginning part of our lecture, learning from mistakes.
I never do it again.
Smart people learn from their mistakes. Wise people, the rest of us, learn from others' mistakes. Yeah. Of course, in the middle of the winter time, it's very hard to drive anything into the asphalt because it'll start chipping and breaking and stuff going all over the place. Yeah, good stuff. Lots of fun. Again, I would also kind of say if you were the professional surveyor who was going to stamp this project, what kind of control are you comfortable with? Ultimately, it comes down to what the surveyor you're working under is comfortable with. However, I would kind of keep that in mind. Do you want something that's durable and going to last and going to stay put? Or are you okay with just kind of half-assing something into the ground? Hopefully, you're not going to be okay with anything half-assed into the ground. Hopefully, the surveyor you work for is not going to be okay with that either. This arm of this thing's kind of a little hard to move this book around. Yeah, so here we talk about referencing. You set a control point. It's in this day and age with GPS and the coordinates and stuff, it's easy to stake out to a traverse point and find it again, control point and find it. However, it's not a bad idea to pull a couple distances off of some existing structures, existing features, so you can find it readily available again. Talking about protecting your control, it's fairly common for you set a iron pin or something like that, take a couple lath, drive it around, and tie some ribbon around to kind of make a little fence to protect that. Or as I very sarcastically and smart-assedly like to say, it just makes a bigger target for the equipment to hit. Try to protect it as well as you possibly can. And that's where I also kind of jokingly was saying, maybe you drive your pin in, don't put much stuff around it. Go 30, 40, 50 feet away and drive in a bunch of stuff, make it look like your controller so the equipment hits that over there and protects your equipment. I actually saw one time, I thought this was brilliant. Some contractors took some 2x4s, took 3 2x4s and cut them so they're about 3 feet tall. Put some braces in between them so they had this 3 foot by 3 foot triangle, and they set that on the ground right by the control point. Those are pretty substantial. They look like, hey, stay out of this area, stay away from it. And the way it was sitting in the ground, it looked like somebody actually like drove these things into the ground. Turns out they were just cut. You could pick them up. But it was like, that's pretty smart. I kind of actually like that idea. If you have access to 2x4s, can cut some and make a little barricade like this picture here that you can set up around your control points, even better.
Spray paint a bunch of cinder blocks, like pink, like take some pink spray paint, a bunch of cinder blocks, stack them up.
Yeah.
Nobody's gonna want to hit that. Or they might just out of spite, I don't know.
Yeah, hard telling. Bulldozer can move cinder blocks pretty easy.
Yeah.
Well, what's that? Oh yeah, track wheels, that don't matter.
Yeah, but spray paint paint, they'll just be like,
What? They're afraid to hit paint on their big manly bulldozer.
It's a big protection of your control is a big challenge for a surveyor. I will say that. Horizontal control, having your primary control, that would be the stuff that's kind of out of the limits of the site, if possible. That stuff should be there forever. theoretically. You can always set up, occupy that, and turn in control onto the site from your primary. Uh, should be protected the best if nothing's going on around it. A lot of times I've seen things where people would set stuff up on the intersections, around the intersections, around the job site of like major roads where there's definitely nothing construction wise happening. Your secondary controls should also be try to keep it permanent, semi permanent. And that can be more on site and around site that you will use to lay out. Again, you want to kind of look at the plans, get familiar with what's going on, the development of the site, try to keep it outside of the developed areas if possible. Your working control, that's going to be stuff where you might turn around and set things very close to where you're working. That's not going to be considered really permanent. It's probably going to get wiped out. Um, almost kind of think of working control as it's probably going to get wiped out as soon as you leave. But regardless, you want to check, and recheck. So when you're set up on your working control, set up on your secondary control, if possible, turn in and measure to, if you're on your working control, try to turn in, be able to check into your secondary control or primary. Just have a check to make sure everything's good. You're still within the right area that you believe you are. Vertical control. Sometimes this can be the same as your horizontal control, whether it's a concrete monument or your iron pin that you set. Other times you can set that completely independent. A lot of times you may see them along the roadways on a fire hydrant. The power companies do not like it, but some people have driven in like railroad spikes or something into the side of a power pole. That is fairly common. However, it's also fairly frowned upon, and probably from a technical legal standpoint, I should say you're not allowed to do that. However, you will see quite a bit of those. I always thought fire hydrants were really good. So when you walk up to the top of a fire hydrant, you should see somewhere there's an arrow pointing on that, kind of telling you, hey, turn the nut this way to loosen it, open it up, open up the valve. Where that arrow is pointing, if you look down, there's usually a bolt that's holding the top flange of that down. And surveyors will call or shoot that particular flange bolt, call it the arrow bolt, whatever bolt's closest to where the arrow is pointing on top of that fire hydrant. Very common there. I had one time at a job site, was driving by or driving out, and I saw the fire department by one of the fire hydrants, and they had the thing completely taken apart. Now, I personally was always thinking fire hydrants are pretty much good, permanent, always going to be there forever. That's never going to move. And here's some firefighters had this thing completely disassembled. So I did stop and ask them what was going on and what they were doing. And they were doing some maintenance on this one particular fire hydrant. I was like, okay, well, as a surveyor, we like to set elevations on this for benchmarks for construction things. I always kind of assumed they never got messed with. I'm like, well, typically we don't. This one had a particular problem they needed to check. Of course, there was another time too where, like, the lone benchmark that survived this project that was about finished, pull up on the job site one day and I look across the street and the fire hydrant's laying on the sidewalk, sideways over. Like, oh, that's not good. Well, I guess we don't have any more true benchmarks left. And that was supposed to be kind of a primary because it was across the street from the actual project site. But, you know, when you get into the inner cities, people don't drive like they have sense. So Fire hydrants get taken out occasionally.
How many bigger companies like set their own monuments around benchmarks?
How many bigger companies set their own benchmarks?
Yeah, like they wanted to set like we use a fire hydrant.
Yeah, well, I mean, that would be something we would set as, I guess, the bigger company, like, hey, for this project control, there's a fire hydrant across the street. We're going to shoot an elevation onto that, put an elevation for project benchmark.
Yeah, you run into like just every now and then do people just set their own monuments just to like I don't know if you do multiple jobs in an area to run back to tie all these jobs into one benchmark.
You trying to think of any jobs where it's like, yeah, I guess thinking of like a commercial job site where, like an industrial park, there's a bunch of buildings getting put in this industrial subdivision, if you will. We had set benchmarks all around that place, and everything that was getting developed was getting developed off of those.
But I don't think they could officially set, like, they asked for it to set it. I don't think they could set it themselves.
They would prefer, probably from more a liability standpoint than anything else, that the surveyor sets the benchmarks than the contractor setting the benchmarks.
Yeah, that's what I'm saying. Like I know Dory's, they'll set their own monuments like to tie their survey work into,
Mm-hmm.
like piece of rebar and concrete. Set that off the side of the road somewhere.
Now, there's also other monuments, maybe county monuments. Cities have their own benchmarks that they want projects tied into.
We're located in an industrial park right now. I stay in tracks right with DOT. And most, if not all of the benchmarks that we shot were
From a third party.
survey. They do them themselves.
It kind of depends. Are you the engineer and surveyor doing everything on one site, or did some surveyor come in and do stuff, and then another engineer came in, and then another surveyor came in to do layout? I mean, it can kind of vary how those benchmarks were established.
I said also who owned the land and who are they hiring? Like if it was owned by a county, then they just do it themselves. But
Yeah,
someone
and particularly around here, there's city benchmarks, there's county level benchmarks in some places, there's NGS benchmarks. Um, However, with the NSRS modernization coming up, a lot of those elevations are going to change. The marks are going to still stay the same. The monuments are going to stay the same. However, the elevation value is going to change because our datums are getting updated.
Let's see if you can answer this question. It's stuff from my father.
I can answer it, but it might not be the right answer. But let's try it.
Because we had to do this dude wanted like a side job done for a boundary, and then it turned into like this big old deal because there was a existing foundation on it that we did, and he wanted to build his house, and then he had a certificate, blah 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 blah, and it just ties into everything because there was a benchmark that we had to go find. I asked him, how do they set benchmarks for elevation if there's nothing like around? So like take it as like the newest piece of land, like in the very beginning type of stuff, the first ever benchmark with elevation.
Well, that all started from like literally differential leveling across the country to establish the first benchmarks. And depending on how far apart those were, yeah, back then they probably ran a level miles from whatever the closest benchmark was to set something on that site and run back.
He told me they could also use the stars and stuff like that.
The stars, you get a horizontal position. I'm not sure how you get an elevation.
That's what I asked him. I was like, so like this is the first ever benchmark ever established, like right here where we were standing. I was like, how did they find that? How did they find that elevation? That's
They came off of another benchmark, however far away that would be, could be miles away, and they ran a level from that benchmark miles down the road to set that and then loop back to that benchmark. This is pre GPS days we're talking.
Oh, I kind of figured because he was like trying else if they had to.
Yeah. 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 That's the good old back in my days, Sonny. We surveyed uphill both ways in the snow, and we liked it. Kind of stuff there.
Because he couldn't understand what I was like trying to find. I was like, think of this first ever benchmark ever posted. How would they
Yeah.
actually get that?
Yeah. Well, our first geodetic reference system here, our elevations, they literally ran differential leveling across the country. They ran control around the country that way, differential leveling, triangulating, setting up on towers, and turning angles and doing the math to come up with those. Now, with the triangulation, you need at least one known distance, and then you can do your triangulating from that, trilateration, where you have distances involved, triangulation. Yeah. So the modernization is going to come up with all the GPS work that has been done, all the satellite data we have, um, the new geoid model, which, if you kind of want to roughly think of a watered down version of mean sea level, was all performed off of leveling, differential leveling, literally across the country. Now it's going to be based off of gravity readings, gravity modeling of the Earth. So it obviously undulates quite a bit. In the mountains where obviously there's more mass of the Earth, it's going to be a little denser. That's going to change compared to the flatlands of like Kansas or northwest Ohio, where it's flat and there's nothing around there. It's going to be very interesting, to say the least. But yeah, if they had to come up with a benchmark, you run it for miles if you had to, because there really was no other way at the time to establish elevation. You had to come off of some known point somewhere.
No, I kind of figured that much.
Benchmark should be solid. Another thing too, common, maybe a corner of a concrete pad of like where there's a transformer setup, or a bridge abutment, things like that aren't going to move or a permanent structure. You put an elevation on there to establish a benchmark. Looks like he's got a fire hydrant, probably showing the arrow bolt there. Recording that. Now it's usually vertical elevation. In this day and age, we put coordinates, so we have a horizontal position as well. But a lot of times, at least back in the olden days, they might not have had a horizontal position on them, other than it's the arrow bolt on this fire hydrant, or it's the spike in the side of this power pole. Power pole's got whatever numbers on it. Record and document. Document and record. Preserving points, preserve them. Referencing, we talked about that again as well. You can just pull a couple distances off of your existing, off of existing features. This you see referencing more common with in sectionalized land, where there's a section corner, there's probably some reference ties, pulling to a tree or a fence or a power pole or something. Pulling so you can pull distances from known visible structures to that location of where that monument's supposed to be. Any questions on any of this stuff so far? Getting pretty close to. It's going to start getting close to time here. talk about methods. I do want you to read this book. I probably will come up with maybe a little quiz on this to make sure you are reading the book. Nothing too crazy. We'll see. I got a lot of other things I need to really worry about, like getting this lab updated. So again, the methods, the 3, 4, 5. That's this ratio of a triangle. Pull a three unit side and a 4 unit side. The hypotenuse will be 5. Radially staking out. That again, that's from setting up on one control point, backsighting another control point, and just spreading everything out. Your baseline, that's where you set up on a known point, backside a known point, establish that baseline, and you're talking about how far along that baseline and how far offset of that baseline. Anybody got any questions on any of that stuff so far? All good? Does anybody have any questions about any of these methods that we should go over here? Triangles, Pythagorean theorem. Anybody ever heard of the Pythagorean theorem before? Anybody familiar with that? Right triangles, know how to calculate a right triangle? Good, good, good. I'd be highly disappointed if nobody knew how to do that yet. Checking technology, radial layouts, procedures for baseline. Intersections, all that good stuff. Okay, well, again, let's just real quick. So the lab this week, oh, there it is. We have a few runs of sanitary manholes, sewer. I believe manhole 1 is the low end. Goes up to 2 to 3 to 4 to 5. We'll see how many runs we can do. Maybe the morning lab we could do 2 runs, and the afternoon lab could do 2 runs. That would be nice. Shouldn't be too terribly difficult. Again, so what we're going to get is you're going to have the top of the casting, top of the rim, top of the manhole, and the invert elevation of each manhole. We'll know the length between those manholes as well as the slope. We will need to calculate what is the pipe elevation at 25, 50, 100, so on and so forth, from the downstream manhole looking upstream. We'll calculate that stuff by hand, then we'll go out and do it in the with the data collector and have it do all of that calculating for you. Anybody have any questions on anything? Dress appropriately for lab on Thursday.